Hello, my name is Scott Tease. I'm the general manager for Lenovo's high performance computing and artificial intelligence team, and I'm really looking forward to speaking with you today. This is the first time in a very long time that I haven't spent part of my June in Germany, but I think doing this virtually will be an interesting and fun time, I hope. Let's go ahead and get into this. I wanted to tell you a little bit about who Lenovo is. We've been a team of HPC experts for about 5.5 years together as HPC Lenovo. I want to tell you a little bit about who we are. And the first thing I wanted to mention is we are a global supercomputing asset. We put supercomputers in the hands of more people, more researchers than any other vendor out there. And we have more listings in the top 500 than anyone else. And people often ask me, how did we do that? What's our kind of recipe for success? And I think it boils down to 4 things. The first is around deep vertical skills. We try to partner with each of our clients, each of our customers, to understand their goals, their limitations, and where they want their future to be. And we adopt that vision for our own and help them drive that forward using IT. The next is around global diversity. What we found over time is that each location around the globe has a different slope to their innovation curve. And learning from those first mover clients and then taking that around the globe has been very, very impactful. It's helped us, drive leadership all around the world. Third is around HPC and AI convergence. We strongly believe they're very connected. First, we believe that HPC knowledge and expertise that we developed will help drive AI for enterprise users all over. And second, we believe that AI can also drive better benefits than traditional HPC approaches. And last but not least here, one of our keys to success is Lenovo Neptune, our liquid cooling. This was technology that was born about 7 years ago in Munich, Germany at LRZ, and now we're starting to see that show up literally all over the world. And you can see here on this chart just a taste of some of the installs that we did last year. And everyone that's marked with Neptune is one of those liquid cooling charts. A few years ago, all of those liquid cooling would have primarily been delivered into Europe, but now it's become kind of a global phenomenon as customers understand the importance of water cooling, not only as an energy efficiency thing, but also as a way to unlock hidden performance, additional performance. Now we live in very exciting times. We're about to enter into a time frame where access to unlimited amounts of computing power and massive scale of computing is going to be the norm. That's something we've never had capability to grasp before. And the challenge is going to move from having enough processing power to do tasks. It's going to move on to us as the researchers in the community to figure out how we apply that thing, how we apply those new technologies, all this new capacity. And as we make our way to exascale, there's really 2 ways we can go. We could build a monolithic design, unique racks, unique fabric, unique power, all kinds of things that you basically build a data center around it. And there'll be 4, 5, 6 of those around the world that get installed in the next couple of years, and we as a community will celebrate. But what we're worried about as Lenovo is that the technologies that were used to build exascale, they have to make their way down to users of all sizes. So we're going to pledge that we're going to build our exascale technologies in a fractal type approach that will allow us to do a petaflop or 360 petaflops or 160 petaflops or 40 or a petaflop, whatever it might be. We want to put these things in standard 19-inch racks. We want to build them on open fabric. We want to use standard power feeds. We're going to make sure they fit through common 2-meter doors. And you would be able to buy the same exact building block, whether you're buying an exascale or a petaflop or something less. And that's a big commitment into the way we engineer our systems to allow that. We call it exascale to every scale. The last thing I'll go over today in our short time together is what we're doing to help drive us forward. When COVID first started to see the outbreak in China, we were looking for partners. And one of the partners that's known for the genomics research is BGI. We actually made a donation of a couple of racks of gear to them. But in addition to the hardware itself, we also donated our GHOST tool, which is the Genomics Optimization and Scalability Toolkit. And what GHOST allows users to do is take traditional timeframes for doing whole genome sequences and whole exome sequences and drives those down to a fraction of time. In fact, with traditional 2-socket IT, we're under 4 hours. And with an 8-way system, we now have that under an hour. So again, it's that combination of know-how, technology and guidance for our clients that is going to make a big difference. So with that, I'll say thank you, and I'll move on to the questions. So the question number one was, with your every scale to exascale to every scale initiative, you're asserting a bit of one size scales to all position. Are exascale systems really merely scaled up commodity clusters? And what I'll say there is that your traditional systems, like your traditional CPU-based systems, probably not a very easy thing to scale up. But the new building blocks that we're getting, the new CPUs, the new accelerators, the new fabrics, they are going to be the building blocks that allow us to build everything from very small systems on up to exascale systems. The key thing is going to be that when you're building these, you can't design without an understanding of what our customers' data centers look like, what their floors look like. You've got to engineer these systems in a way that allow users of all sizes to take advantage of it. And I think you'll see that in a lot of our next generation systems. The next question here, given your reliance on standard and open components, is there any secret sauce that Lenovo provides or truly can provide with these types of systems? Well, I think there's a lot of different things you could consider secret sauce. I mean, it could be everything from the way we deploy systems to our management software we call LECO, to our quality, to our reliability. One thing I mentioned in the talk today was around our Neptune liquid cooling. I think what people are going to realize is that liquid cooling is going to move from a nice to have for an energy efficiency type green initiative to something that's going to be a requirement to allow us to continue to stay on the hardware roadmaps of the GPU vendors and the CPU vendors. We're getting so much density, so much performance in such small spaces that we're going to need water cooling, liquid cooling to unlock that and continue to drive forward. So yeah, there's plenty of different opportunities for us to differentiate in on top of open technologies. Third question, do you believe that x86 system vendors can differentiate their offerings? If so, what are the areas that are up for differentiation? Well, I think this one is fairly similar to the last question, but one area that I'd like to dive a little bit deeper on is power, packaging, and cooling. I'll have to admit that a lot of people take that for granted. They think they would just buy a 1U or a half U server and it's pretty easy to package those things. But as we go forward in time, as I mentioned, we're starting to get component power consumptions and sizes that are going to make carrying on the traditional approaches that we've done in the past very different. No longer are we going to be as concerned about what the room can handle. Our new effort is going to make sure that these components fit inside of the package that you're used to seeing. So if you're used to buying a half-U server, we want to make sure systems still can be packaged in that half-U environment. If you're to buy in a 1U, we want to make sure it can be run and packaged properly balanced inside of that 1U system. So I think what you'll see in the past, we had issues where the room limited what we could place in any given environment. The new challenge, the new paradigm is going to be that not only will the room still be a limitation for us as power goes higher, but physically fitting these things into the packaging that that customers are used to seeing, that's going to be a real challenge. There's going to be a lot of room for differentiation in the way that different vendors approach design, and I'm excited about that. All right, so the last question was around what is Lenovo doing to help customers and/or employees during the ongoing COVID-19 crisis? Well, so the first thing we did was we were very early telling all of our employees that they should work from home to ensure safety of themselves and their families. We also offered up the use of any of our HPC Innovation Center assets to anyone that was doing COVID research. We wanted to make sure that if people had good ideas, we could provide them quick access to tools so they didn't have to wait to get things online or go out to an unoptimized cloud form factor. They could get quick access to an HPC cluster right away. Lenovo itself has been donating gear, as I mentioned in the fight against COVID. Some of the customers you saw on the earlier page, a lot of those customers are doing COVID research. We donated gear to the new hospitals that were being set up right on the front line of this COVID outbreak. We've been donating equipment to schools to help them take their mission of teaching our kids online because they couldn't do it in the classroom. We are matching all of our employee donations right now in charitable giving. So again, I think it's a pretty holistic look at what we're doing to help during this crisis. We're all kind of coming together as a global community to fight this thing. So with that, I'll say thank you.